This is 342, which is Boolean logic. So we've given a truth table here for the OR gate. Now an OR gate will output true whenever one of the inputs is true. So 0 is false and 1 is true. So if they're both false, then the output must also be false. One of these is on, so the output will be true. One of these is on, so the output will be true. Now both are on, but still one of them is on, so that's still classed as true. So that's your OR gate. We're then given a truth table for the logic circuit. So there's the truth table and there's a logic circuit. So we must know what these symbols are in order to understand the actual diagram. So that is an AND gate and that is a NOT gate. An AND gate, they both, so AND both must be true, and a NOT gate will always do the opposite of the input. So if we look here, we've just got to read it line by line to see what's going on. So if both are off, so if both of these inputs here are off, including that one, because it's going to spread to that one as well. So let's just see what this is. A little bit confusing. So this is going to be off, this is going to be off, which is in turn going to make that one off and that one off. So X will be off, so it will be false. Y will also be false, and Z, because it's a NOT gate, it will do the opposite, so it'll be a 1, because the Y coming in is off, so the output is on or true. So now we've got, so I'm just going to rub these out so I don't get mixed up. So now we've got a 0 and a 1. So A is 0 and B is 1. So let's just step it through again. So 1, that's going to carry all the way to here and be a 1. 1 is going to go there and there. And then if we carry this on down here, because they're not both on, this will still be a 0. And then again, these are both not on, so it'll still be a 0. So that will be the opposite, which is on. So it's all false, false, true. The same thing again. Okay, so I'm just going to rub those out again, so I don't get confused. So now we've got A is on and B is off. So now we've got to carry it through again. So B will be off there as well. A will be on there, but it'll carry up and off there. The output from that will be off. So there's 2 offs now. So that's definitely an off. And then we've got the opposite of that, which is a 1. So now we've got 0, 0, 1. So they've all been the same so far. It's getting a little bit messy. This is why in the exam you'd probably have a pencil and a rubber to help you with this so it doesn't get too messy. So we've got here A and B are both on this time. So now we're sending power up here and power here. We've got power going to here and power going to here. So then it's going to output power, which means the NOT gate will do the opposite. So X and Y will be on this time, and the opposite of that is off. So that's going to be your false. So a logic circuit is developed for an automatic door system. The automatic door has two sensors, one on either side of the door, sensor F and sensor B. The door opens when either of these sensors is activated. The door system can also be turned on or off using a manual switch with S. The door will not open unless S is on. The output from this logic circuit for whether the door is open or not is D. Complete the logic circuit diagram for this system. So if we take a look at this again, we've got the automatic door has two sensors. So one's going to be for the inside and one's going to be for the outside, so that's F or B. The door opens when either of these sensors is activated. So that word either there gives us a clue there that we're going to need an OR gate. So let's just try putting an OR gate in here and just see what happens, see if we can get it to work. The door system can also be turned on or off using a manual switch. So we're definitely going to need some power coming through this switch as well. The door will not open unless S is on. So this always needs to have power coming through it regardless. So we don't want any kind of switch there before a final gate comes here. So we've got the output from this logic circuit for whether the door is open or not is D. Okay. The door system can also be turned on or off using a manual switch S. The door will not open unless S is on. So let's think about the output that's going to happen from here. So this is an OR gate. So if this is on or this is off, you're still going to get electric current coming through. If this is on and this is off, you're still going to get electronic current coming through. If they're both off, you won't get any, and if they're both on, you'll get electric current. So we can be pretty certain that this is the right gate that we've got to use here. Now, in order for D to be switched on, we need to have some input from here and some input from here. So the clue there was, if we look, the door system can also be turned on and off. The door will not open unless S is on. So we need the door to be opened when somebody presses F or B and when it's manually switched on as well. So I'm using the word and a lot there. So I'm thinking that the AND gate is going to be the sensible one to use here, because we just put that as an output, because if one of these is switched on and one is off, then the current will go through, and when this is manually switched on, the current will go through, and they both need to be switched on in order to produce the output for D. So I'm pretty confident with my diagram there that I've drawn.